Alright, so now we're moving on to 11.4, which is spheres. There are two parts to this. The first part, we're actually doing the surface area again. We're back to the surface area. Eventually we go back on to volume, but as I say, at the moment we're starting with surface area. And we've got several new vocabulary. A greater circle, the poles and a hemisphere, okay, but there is another one in some textbook, the lesser circle, and you'll see where that fits in a minute. Okay, so but before we get on to that, the vocabulary, let's have a look at what we do for the surface area. Again, you've got a formula, it's on your formula sheet as well. It's 4 times whatever pi times the radius squared is. Okay, so surface area is 4 times pi times the radius squared. So let's have a look and see how that fits into example 1. Okay, you've got to find the surface area of the sphere to the nearest tenth, and you're told from the diagram that the radius is 6. So again, sometimes it's going to be radius, sometimes it's going to be diameter. So make sure if it's diameter, you divide it by 2. And again, your formula is given. Second line is just the only one you can substitute is whatever the radius is. Plug it into your calculator and round it to the nearest tenth, so you're left with 452.4 centimeters squared. And we're doing example 2 at the same time. Alright, so let's have a look at what we've got. Right, so example 2 says find the surface area of a hemisphere. Okay, in other words, it's half of the world. Imagine from the equator upwards. Okay, so you've got to find the surface area. Well, the 4 pi r squared is for the whole of it. Well, you only want half of it, so that's where the half comes in. And don't forget, you need to find the area of the base as well. Okay, and again, from the diagram they've given you the radius, which is 2.8. So your second line is just substituting. Basically, the only thing you're substituting in is your radius of 2.8. Calculate a job again. And again, unless they tell you otherwise, just round it up to 1 decimal place, which in this case is 73.9. Okay, so let's have a look at examples 1 and 2 in play with question number 1 and question number 2. So let's have a look at number 1. Number 1, you've got a globe, a sphere. It wants to find the surface area round to the nearest tenth. So area is equal to, don't forget, it's 4 pi r squared. Okay, so 4 times whatever pi is times 9 squared, and again it's all calculator and it is all multiplying, so plug it in and you will finish up with 1017.9 to 1 decimal place, and that is meters squared. Okay, so there's question number 1, but let's have a look at question number 2 and how does that differ. Well, this time you've got a hemisphere. So basically you've got only half of your sphere, so it's a half times 4 pi r squared. Okay, and then you've got to add on to that the area of the base, which you know is pi r squared. Okay, well the diameter is 14, so the radius equals 7. So again, just plug everything into your calculator, so that's a half times 4 times pi times 7 squared, and you're going to add on to that, pi times 7 squared. Okay, and if you plug that into your calculator, make sure you use parentheses around here and here and around here and that one, and that way it'll add together correctly and you finish up with 461.8. Okay, and that this time is inches squared. Okay, so now we're moving on to volume of a sphere, and again now we've got our formula, and again it's on your reference sheet, or it will be on reference sheets whenever you do exams or anything like that, so don't panic. Okay, so the volume of a sphere is 4/3 pi r cubed, because don't forget this time it's volume, so it's 3-dimensional, so it's cubed. Alright, so let's have a look at example 3. So either the volume of a sphere or a volume of the hemisphere. Well, in example 3a, you've actually got the volume of a sphere, but a hemisphere. So this time we've still got our 4/3 pi r cubed, but we need a half of it. Okay, so start plugging things in. I mean, you can cancel it down if you want, but just leave it at that. So a half times 4 over 3, and then that is 4 over 6. If you multiply them together and simplify, that is 2/3. So that's where you get the 2/3 from. Pi r cubed, so 6 cubed. And again, plug it into your calculator, and you've got 452.4. And because you want the volume, you don't have to do the base. It's already part and parcel of the circle. Okay, in example B, this time they've told you what the circumference is, so you've got to work back from the circumference all the way down to the radius. Okay, so substituting, they've told you that the circumference is 18 pi and your formula is 2 pi r. Then by subtracting and dividing through, you get to radius is equal to 9. Quote the formula, plug your 9 in, and you come up with your solution. Okay, so now we're on number 5, we're looking at the volume. So volume is equal to 4 over 3 pi r cubed. Okay, and they've told you that the radius is 10 and you need it to the nearest tenth. So again, calculator job. Okay, your 4 over 3, your pi, and then don't forget your radius is 10 cubed. Alright, and when you plug that into your calculator, you finish up with 4188.8, and this time it's feet cubed. Okay, so so that was number 5. So let's have a look at number 7. Alright, this time we've got a hemisphere, and it's told you that the circumference is 24 pi. So we need the radius. So the first thing we've got to do is 24 pi divided by, if we do 2 pi, that will automatically give us the radius. So the radius equals 12. Okay, so now we've found the radius of that hemisphere. Now we can plug it straight in. So don't forget, it's a hemisphere, so volume is equal, we only want 1/2 of it. So 1/2, then 4 over 3 pi and 12 cubed. Okay, and if you plug that into your calculator, you should get 3619.1. Okay, and it's whatever the units are, meters cubed. Alright, and as you can see what they're doing in example 4, they're actually telling you what the volume is, which is 8.65, but they want you to find the circumference. So they're actually making you do several things in one. Okay, here's the formula, 4 over 3 pi r cubed, and you've been told that the volume is that, so working backwards. Okay, so if you divide 8.65 by 4 over 3 pi, you get 2.06, and that is the radius cubed, so you need to cube root 2.06. Okay, and you finish up with 1.3. And you know that the circumference is 2 pi r, going back to the area of a circle, or the circumference of a circle I should say. Plug in your numbers and put it into your calculator. So your circumference of the circle is 8.2. So this is working backwards from the volume to find something else instead of the radius or the diameter. They're now finding the circumference. So be careful, make sure you read the question, it will tell you what you've got to do first. Okay, so let's have a look at example 4, question number 9. Basketballs used in professional games must have a circumference of 29.5, and again the surface area. Okay, so now they're asking you again to do 2 parts. So the first thing you need to do is find the radius. Well, don't forget your formula is for the circumference is 2 pi r. Okay, now if you substitute in, this time you've got 29, and I'm going to put it as 29.5 equals 2 pi r. Okay, and if you divide through by 2 pi, then you'll get whatever the radius is. So the radius is equal to 29.5 divided by 2 pi, and if you put that in your calculator, you will get 4.7. Okay, and that is obviously inches. So now you've got whatever the radius is, now you've got to find the surface area. So now we're back to surface area. So area is equal, and it's 4 pi r squared, remember. Okay, and so A is equal to 4 times pi times 4.7 squared. And if you put that all into your calculator, your area is actually 277 inches squared, because don't forget we've gone from volume to area, so area is 277. It's not asking for any decimal places, so I'm going to leave it at 277.